In 6.4, we will continue to solve linear systems by multiplying the systems first. Right? So I sort of alluded to this in 6.3. Sometimes when the two equations are not appropriately composed, adding or subtracting won't eliminate a variable. And when that happens, what I can do is I can multiply the equations by a value in order to create the scenario that I need. So let's see what that looks like. If you take a look at this linear system, you can see that if I add these together right now, I'm not going to be able to make either of these variables drop out. My choice is I could multiply the second equation by 3, add them together and get the x to drop out, or I could multiply the second equation by 2 and make the y drop out, and that's what I'm going to do. So I'm going to multiply this by 2. The first equation, I don't have to change anything. So I'm just bringing that across. I multiply this one by 2, so I'll have negative 2x plus 2y equals 2. When I add everything together, I get x here. These drop out. That was my plan. And 3 plus 2 is 5. So I just go right to x is equal to 5. When I take the 5 and I plug it back into, I'm going to plug it into this second equation. So I have the opposite of 5 plus y is equal to 1. If I add 5 to either side, y is equal to 6. And there I've solved my system. So I'm always allowed to follow the rules of algebra and multiply either side of the equation by a number, by the same number. Right? Just make sure that when you do that, you're multiplying all the terms by that number. I had to multiply the x, the y, and the 1 by 2 in order to make it be accurate. Let's try this in another way. Okay, so when you look at this one, now here's a problem. I can't multiply the 2 by any number to make it be the opposite of 3, nor can I multiply 5 by a number to make it the opposite of 11. So I'm going to have to multiply both equations. Okay, but if I multiply the top equation by 3, I'll get negative 6x minus 15y equals 27. And if I multiply the second equation by 2, I'll get 6x, and this is what I wanted. I have opposites now. Plus 22y equals 8. And now when I add these together, the x's will drop out. So the x's become nothing. Negative 15 plus 22 is 7y, and 27 plus 8 is 35, so y is equal to 5. That's nice. If I plug that back in for one of these values, I'm going to plug it into the top one. I'll get negative 2x minus 5 times 5 equals 9. So negative 2x minus 25 is equal to 9. When I add 25 to either side, negative 2x is equal to 34. And dividing by negative 2x is equal to negative 17. Okay, so sometimes I can multiply one equation, like in the last example, or I need to multiply both equations by something, like in this example. The key is I'm always looking to make sure that I can eliminate one variable. If you look on this one, it was very easy to make the one variable drop out just by altering one equation, but instead I had to alter both. Now here we've got a situation where we've got a whole bunch of decimals, and maybe you don't like working with decimals. I personally don't really like working with decimals. So the first thing I'm going to do is I'm going to get rid of all the decimals, and I can do that by multiplying everything by 10. So in both equations, I'm going to multiply everything by 10 to get rid of all these decimals. Because frankly, I don't want to try to figure out what to multiply 1.5 by to get it to be the opposite of 1.2. I find that a little confusing. I'm acknowledging my personal limitations, and I'm going to choose the path by which I go through the problem accordingly. Negative 12x plus 25y is equal to 10. So there, I've gotten rid of all the decimals by multiplying every single term by 10. So I moved all the decimal places 1. Now when I look at it, I go, well, I can see, for instance, now we're going to look at how do I find the least common multiple. There are a couple of ways I could go about it. I'm going to do it in the math way first. I know that 15 is 3 times 5, and I know that 12 is 3 times 4. So the 3's are common. What's going to be important is the 4 and the 5. So if I multiply this by 4, if I multiply the first equation by the 4 and the second equation by the 5, these will become a common multiple, and that multiple is 60. Okay. Equally, I could have done a more organic way, which is maybe I have 15, 12 is not a factor. If I multiply 15 by 2, I get 30, 12 is not a factor. If I multiply 15 by 3, I get 45, 12 is not a factor. If I multiply by 4, I get 60, and 12 is a factor of that. So this equation I'm going to multiply by 4, and this equation I'm going to multiply by 5, and we're going to write two new equations. So I'll have 60x minus 140y equals negative 200. And here I'll have negative 60x. That's what I wanted. These are opposites. They're going to drop out. 5 times 25 is 125. And 5 times 10 is 50. Okay, so when we go ahead and I'm sorry, I said 14. I wrote 14, but that was 140. My mistake. I apologize. 60 plus 60 plus negative 60 is 0. Negative 140 plus 125 is negative 15y. And negative 200 plus 50 is negative 150. So y will be equal to 10. Then I could go back and I could plug into one of these equations, or I could plug into those equations, or I could plug into these equations. Any one I want to. They're all equivalent. Okay, but I'm going to go ahead and I'm going to plug it into, I think I'm going to plug it into the second equation. So I'll have negative 12x plus 25 times 10 is equal to 10. So I'll have negative 12x plus 250 is equal to 10. Negative 12x is equal to negative 240 by subtracting the 250. And dividing by negative 12, x is equal to 20. So my solution is the point 20, 10. Okay, so that would be, I'm going to put that here, 20, 10 is my solution. Okay, remember I created this scenario where these were opposites and they dropped out. Okay, and that's the solution to the previous problem. Okay, let's take a look at some more. So if I want to go ahead and apply this to some sort of a real-world construct, I have a rectangle that has a perimeter of 18 inches. And I make a new rectangle. So let's say here's my rectangle. And it's got a perimeter of 18 inches. I'm just going to write the perimeter in the middle. Normally I would do that with area, but I'm doing it with perimeter. And I make a new rectangle, which is going to double the width, right? And then it's going to triple the length. And the new perimeter is 46. Okay? So I've got a width of W. So when we look at this, this is W, and then this distance here is double that, so 2W. And then here's my length, L, and this length was triple that, so that's 3L. Right? So if I want to solve a system of linear equations, I can go ahead and solve this. So I'm going to write the perimeter of each of the two rectangles. So I know that 2L plus 2W equals 18 for the first rectangle. And then I'm going to have two of these and these are 3L, so that's going to be 6L, and 2 of these, which is going to be 4W, and it's going to equal 46. If I go ahead and solve these, then I'll be able to find the value. So what I'm going to do is I'm going to multiply the top equation times 2, and I'm going to rewrite it down here below the other one so I can subtract. So I'll have 4L plus 4W equals 36. And when I subtract, I'll get 2L here. These will drop out. Remember, that was my goal. I'm creating opposites. Or in this case, I didn't make opposites. I made things that were the same so I could subtract. Opposites for adding. That's going to be equal to 10. So L is equal to 5. Okay, so if the length is 5, if I go back to the original equation, length is 5, I know that 2 times L, that's going to be 10, plus 2 times W equals 18. When I subtract 10, I'll get 2W is equal to 8. So W is equal to 4. So when I find the length in which the second rectangle, the length was 3 times L. So 3 times 5 is 15. And the width was 2W. So that's 2 times 4 is 8. And now I found the length and width of the second rectangle. To give a follow-up on the concepts we've been working with in this chapter, there are many different ways to go about solving linear systems. We could create a table, this is really unwieldy and unlikely, but you can see that when my y's are the same, when my x's and my y's are the same, then I found the intersecting point. I can graph and look for the intersecting point, which would be here. I can do substitution, addition, subtraction, and then I can multiply first in order to do addition or subtraction. Okay, equally I could divide so that I can do substitution. Either one. We can do any of the things that are legitimately appropriate in algebra in order to arrange the equations to be able to accomplish our goal, which is solving the system.